My topic is Basics of C Program, and myself, Nandhini, Assistant Professor, Department of Computer Science. Here is my agenda. My first slide focuses about introduction of C program, and my second topic is executing a C program, and my third one is variable, data type, and functions. Finally, I am concluding the basic structure of a C program. Next thing, we'll focus about our introduction. Before moving into what is a C program, first let us learn about what is a programming language. So programming language, it is a language in which user is going to give a set of instructions. Based on that instructions, computer will execute your program and performs the specific task. And then focusing about C, it was developed by Dennis Ritchie at Bell Laboratories in 1972. So C is called as the mother of many programming languages, which means modern programming languages like C++, Java and C Sharp, which is based on C. Hence, C is considered as the mother of all programming languages. C is regarded as general purpose and procedural programming language, which means programs were written in step-by-step order and executed based on the function. C is mainly widely used to develop embedded systems and operating systems like Unix and then system software applications. My next slide focus on executing a C program. How a C program is executed based on these 4 steps. My first step is creating a program. In this step, user will write a source code in a text editor and then he'll save it with .c extension. This is what our first step, creating a C program. My second step focus on compiling the program. Once we write a C program source code and save it as .c extension, we have to compile the source code. For this, we will use a compiler. Compiler will check for the syntax errors in the program and report it to the user. When the user corrects the syntax error, then the source code gets converted to object code. Object code means machine understandable code. It gets converted to machine understandable format. That is what the compiling process. Our third step focus on linking the program. Once the program gets compiled, it gets converted to object code, right? Next process is our linker will link that object code with the C library functions. Then it gets converted to an executable format, which means .exe extension. And finally, our fourth step is executing the program. When the program gets converted to .exe extension, it is ready for the running process. Our operating system will load that executable file into the memory and the CPU will read those instructions and then process our program and give the desired result in our screen. Here is the flow diagram of our program. First thing, our system is ready. Next, we'll enter our source program and we'll save it as .c extension. Next thing, our source program will get compiled by using a compiler. Our compiler will check for the syntax error. Once there is no error, next step it will go to the linker function. If there is error, it is the user responsibility to correct the syntax error. It will spot the required line for the error. User will observe that required line for syntax error and correct those errors. Next step, our program will move into the linker section. In this linker section, our program gets converted to executable file. That is, the object file will get converted to executable file. Next thing, once it gets converted to executable file, our CPU will process those instructions. If there is any logical errors in your program, it will go to the previous step, which is executable state. In this, user have to give the correct input and then the program again came to CPU. CPU fetch those instructions and finally our desired output will be displayed on our screen. Here is what the entire flow diagram of your C program. And this is what the flow diagram explanation. First is the program code. First we'll enter a source program in source editor and save it with .c extension. Next thing, we'll check for the compiler for errors. If the error exit, they have to be corrected. Then the compilation is again repeated. Next, linker function, we have to link our object code with the system library. Then it gets converted to executable code. Then finally, the executable code will get processed by the CPU. If there is any logical error, the user have to give the correct input. Finally, the correct output will be displayed on our screen. And my next slide focus on variable. Before moving into our program, we'll have to know the concept of variable, data type and functions. Now we focus on what is a variable. A variable is a named memory location that is used to store a value. When we want to store a value in our computer, we have to declare a variable for that value to store it in our memory. Here see our example, int age equal to 20. Here age is a variable which hold the value 20. So in order to store this 20 value to your memory in your computer, you have to declare a variable. That is what age. Here age is the variable and 20 is the value stored inside that variable. And here the age is declared as an integer data type. Next topic we'll see about this integer data type. First thing, what is variable means? It is in order to store a value, we have to use a named memory location. That is what the variable is. Next thing is data type. As we already seen in our previous example, a data type specifies the type of data a variable can hold. What value a variable can hold will be specified by the data type. There are four common data types in C. A data type will store different memory locations for different kinds of data. For example, if it is int means it is an integer data type which will occupy 4 bytes and it will store only the whole numbers. Here are the examples 10, 100, -5 are the whole numbers. Next data type is float. It will occupy 4 bytes and it stores only the decimal numbers. Here are the examples 3.14 and 5.5 where there are their values stored in the float data type. Third data type is character which occupies only 1 byte, that it stores only a single character. Examples were A, B. Next data type is double. It occupies 8 bytes. It stores large decimal numbers with more precision. Here is an example 10.234567. These were the examples of these required data types. Next thing we'll focus upon function. A function, it is a block of code that performs a specific task. When we want to perform a specific task, instead of writing a set of code repeatedly, we'll declare a function and place that set of code inside a function. When the main function will call the user-defined function means it will call several times instead of writing the same code repeatedly. Simple idea regarding function is, it is like a small machine that does a particular job when it is called. It is a real life analogy for a function. Let us focus on an example. In this example, void display is a function. Inside that function, we are placing a printf statement stating hello. When we call the display function means, only this print statement hello will get executed as our output. Next, we move on to our last topic, basic structure of a C program. In this basic structure, we focus upon these upcoming sections. First section is documentation section. In this, we'll write the title of the program and then author name and then date in which the program is created. It will ignore all the command line sections in your program. Second section is link section, which includes the include header files in the link section. In this example, I am stating this header file include stdio.h, which means standard input output. If you want to give input output functions in your C programming language, we'll have to mention this header file. Then only the printf scanf statements will get supported. Third section is definition section. In this definition section, we'll define our symbolic constant. As a rule for a symbolic constant is we have to put as the first symbol and then we have to define our symbolic constant by using the define. statement, and then our symbolic constant should be in capital letter, so that I'll give pi as capital P and capital I, which hold the value 3.14. This is the general format for defining a symbolic constant that will be given in our definition section. Our fourth section is global declaration section. Any variable or any function which is declared above the main function is called global declaration. And then fifth is our main function. Main function consists of two parts, which is declaration part and then executable part. Our declaration part contains only the variable declaration. For example, int a comma b. A and b were the variables of integer data type. That is what the declaration part. And our next part is what the executable part, which contains the statements that has to be executed. If you want to perform an addition of two numbers, we'll declare a plus b. That executable part comes under this executable part section. Our final is what the subprogram section. In this subprogram section, we'll define our user-defined function. When we want to process a set of code multiple times, we'll declare a user-defined function and place that code within the function. Whenever that function is called, that repeated code will get executed repeatedly. Here is a sample program for our section. First documentation section, in this we'll give the title of the program. Second, in link section, we'll include the libraries, that is standard input and output header files were included in this link section. And then in definition section, we'll define the symbolic constant. Here my symbolic constant is pi. So I declared in the definition section by stating hash define and then followed by pi and then followed by its value. Third is global declaration section. Any variable or function which is declared above the main function will be treated as global declaration. Here my variable num and the function display is declared as global declaration, and then my function move on to the main function. Whenever a program starts executing, it first starts with your main function. Here is my main function is getting started. Inside my main function, I have declared three variables of integer data type. Sum is a variable, b is a variable, a is a variable. In this, I have assigned a as 10, b as 5. This is what your declaration part. As we already seen, main function consists of declaration part and executable part. Assigning a value to a variable comes under your declaration part. Performing a calculation comes under the executable part in your main function. Finally, we are printing that value sum, and then we'll see the result in our screen. In this main function, we further added a small step, which is what a display function. Display is a function. In main function, we are calling that function inside a main function. When this function is called, our cursor will move on to the word searching the display. Here display is a user-defined function. In this user-defined function, I have performed a calculation, which is num is equal to pi into 2. Here the value of pi is not known to display and not known to main function. But here the pi is declared in global declaration. So it will get the value of pi from the global declaration and calculate the value of num as pi into 2 and then print the value of num in your output screen. This is what the program to understand all the sections in your basic structure of a C program. Finally, I am concluding my topic. So in this presentation, you have learned basic concepts of C programming, and then what is the introduction to C, how it is getting executed, and then we'll see the concepts of data types, variables and functions, and then we'll discuss about basic structure of C program in our presentation. From this, you all get a foundation of C program. Through these, you will write a simple program and develop some logical thinking to write your own C program. Thank you.